Swayam Prabha. Digital India. Educated India.
Now we are going to discuss how to use the concept of this fuzzy Siemens algorithm to solve one numerical example. Now, the numerical example which I have taken here is a very practical example. The example is as follows, like supposing that we want to carry out some sort of machining operation to generate the free-form surface. Now, the free-form surface is actually a bit difficult to do the machining. Now, a very good example of free-form surface could be the surface of your, so this mouse, this is an example. Now, how to do this type of the machining or how to generate, so this type of surface. Now, this is a simple one, but if there are so many such ups and downs, for example, the surface which I have considered here. So, how to carry out the machining. Now, if you see this particular surface, so what you do is the nature of the surface is something like this. Say I have got this is the 3 dimension like x, y and z, and the surface nature of the surface is something like this. So, this could be actually the nature of the surface, and here if you see, so we have got so this type of undulations. So, there are large number of undulations here, and we will have to do the machining just to generate the free-form surface. Now, what we do is we take the help of some milling cutter. Now, as there are so many such ups and downs on this particular surface, so this milling cutter will have to utilize in an optimal sense, and truly speaking the machining has to be done cluster wise. So, this surface we try to divide into a number of clusters based on the similarity, and after that for each particular cluster we do the machining in one way, and for another cluster we will have to do the machining in another way. And to decide that particular what should be the strategy of machining, so that we can get a very accurate free-form surface, we may take the example or we may take the help of so this type of clustering or the fuzzy clustering. Now, let us see how to solve so this type of problem. Now, here for simplicity what I have done is I have considered the 10 points only for your the lying on the free-form surface, and I have tried to show you like how to do the clustering, so that we can select the machining strategy accordingly. Now, let us see how to proceed with so this type of the clustering. Now, as I told that we have considered for simplicity only 10 points, so that I can show you the hand calculation, but truly speaking on the surface you will have to generate a large number of points like 1000 points, 10,000 points, something like this. But for this numerical example I have just considered 10 points selected at random, and these points are lying on the free-form surface. And let us see like how to do the clustering. For example, the first point, the x dimension is 0.2, y coordinate is 0.4 and z coordinate is 0.6 and so on. So, for each of the 10 points we have got x, y and z coordinates, and as I told, so these points are in fact those are lying on the surface of the say the free-form surface. Now, what is our task? We will have to carry out the clustering using fuzzy Siemens algorithm, and we are going to assume that the level of cluster fuzziness, that is G, is 1.25, and termination criteria, that is epsilon, we have considered 0.01. Now, let us see how to proceed with the clustering. Now, here the number of data points we have considered, that is equal to 10, for simplicity, only 10 points I have considered, and each data point is having the dimension 3 like your x, y and z. The level of cluster fuzziness we have assumed that g equals to 1.25, and let us assume that there could be only 2 clusters, because I have considered only 10 points. So, better to go for only 2 clusters, and let us see how does it work, how to explain the working principle of this Fuzzy-Simmons algorithm to solve this numerical example. Now, what we do is, so initially we assume the membership matrix that is denoted by mu, and what is the size of this particular mu? It is nothing but 10 cross 2. Now, why 10 cross 2? Because we have got 10 data points and we have considered only 2 cluster centers. Now, corresponding to the first data point, so it has got the membership with the 2 clusters. So, this is the membership with corresponding to the first point with respect to the first cluster center. So, this is the membership value corresponding to the first data point with respect to the second cluster center. So, this is the membership function value, and if you add them up, so this will become equal to 1.0, and the same is true for each of these entries. So, this is the membership values for the second data point, membership values for the third data point, for the fourth data point, and if you add them up, you will be getting 1.0. And this particular matrix, the mu matrix of size 10 cross 2, this is generated at random initially. Now, let us see how to proceed further and how can you do the clustering. Now, I am just going to determine what should be the first dimension of the first cluster center, and that is denoted by is your CC11. If you remember that particular expression which I use, CCJK. Now, what is that? That is nothing but the kth dimension of the jth cluster center, and CC11 is nothing but the first dimension of the first cluster center. Now, the first dimension of the first cluster center. So, I am just going to find out. Now, how to do it? The same formula which I have derived, that is summation I equals to 1 to n mu I 1 raised to the power g multiplied by x I 1 divided by summation I equals to 1 to n mu I 1 raised to the power g, and that I am assuming that it is a divided by v. Now, let us see how to determine so this particular a and b. Now, to calculate a, so you concentrate here. So, mu I 1 raised to the power g, and I varies from 1 to n. N is the total number of data points. Now, what does it mean? The moment I put I equals to 1, so this is nothing but mu 1 raised to the power g. What is mu 1? Mu 1 is nothing but thus the membership value of the first data point with respect to the first cluster center. So, membership value of the first data point with respect to the first cluster center. Now, if you see the previous this thing, the membership value of the first data point with respect to the first cluster center. So, this is actually the numerical value. Okay. Now, similarly, the membership value of the second point, second data point with respect to the first cluster center, this is nothing but the mu value. Similarly, the membership value of the third data point with respect to the first cluster center is nothing but, so this particular the numerical value, and corresponding to your the first the data point. If you see the first data point, if you see, so the x dimension is nothing but 0.2, second data point, if you see the x dimension is your 0.4, third data point the x dimension is 0.8 and so on. Now, I am just going to use all such information here. Okay. Now, A is nothing but, so this particular expression, and I am just going to put first your I is equals to 1. So, it is mu 1 raised to the power g multiplied by x 1. Now, x 1 means what? The first data point, first dimension. So, that is 0.2 and this is the membership value raised to the power 1.25. The next is I equals to 2, that means your mu 21 raised to the power g, that is your the membership value of the second data point with respect to the first cluster center, and this is nothing but this multiplied by x 21. What does it mean? It means that the second data point first dimension, and that is your 0.4. Similarly, this when I equals to 3, this is the scenario, then I equals to 4, I equals to 5, I equals to 6, I equals to 7, 8, 9 and I equals to 10. So, by following this, and if you just simplify, so I will be getting one numerical value for A, and that is nothing but 1.912120. So, this is nothing but the numerical value for A. So, I hope this is clear to all of you, and now I will have to find out what is B. Now, to find out this particular B, so B is nothing but, so mu I 1 raised to the power g and I varies from 1 to n. So, I put I equals to 1, next time I equals to 2, I equals to 3, then at the end I equals to n. Now, if I do that, then very easily I will be able to find out B, that is nothing but 0.680551 raised to the power 1.25 plus 0.495150 raised to the power 1.25, and this corresponds to in fact I equals to your 2. Similarly, I equals to 3, 4, I equals to 5, I equals to 6. So, this is the way actually we can find out, and we can consider for all the data points, and ultimately you will be getting your the B. And once you have got this particular B, so CC1, that is what? That is nothing but is your for the first cluster center, the first dimension. So, the first dimension of the first cluster center, let me once again write CCJK is the kth dimension of the jth cluster center, and CC11 is the first dimension of the first cluster center, and I will be getting 0.487404. And by following the same procedure, I can find out what is CC12, and that is nothing but the second dimension of the first cluster center. Then comes your CC13, and that is nothing but the third dimension of the first cluster center, and that is your 0.543316. And similarly, we can find out CC21, that is the first dimension of the second cluster center, CC22 second dimension of the second cluster center, that is 0.459073, and by following the same procedure I can also find out CC23, that is your the third dimension of the second cluster center. So, I will be getting this particular the numerical value, and once you have got this particular the numerical value, now the coordinates of my cluster centers are known and these are determined. So, we have got the C1, that is the first cluster center, and its corresponding the first dimension, second dimension and the third dimension, because these are all 3D data, and for the second cluster center the first dimension, second dimension and the third dimension. Now, once you have got it, what you will have to do is you will have to update this mu. That means, I will have to update the membership value of a particular data point with respect to the clusters. So, how to update? Now, to update that, so this formula I have already derived. So, this mu 1 1 is nothing but 1 divided by 1 plus d 1 1 divided by d 1 2 raised to the power 2 divided by g minus 1. Now, you will have to substitute the values for this particular g, that is the level of cluster fuzziness, which is 1.25 here. We will have to find out the Euclidean distance, that is 1 1 and 1 2. What is 1 1? So, if you remember, the d I j is the Euclidean distance between the ith data point and the jth cluster center. So, this d 1 1 is nothing but the Euclidean distance between the first data point and the first cluster, and d 1 2 is the Euclidean distance between the first data point and the second cluster. So, how to determine that? To determine this, actually, so mathematically we can calculate. So, this d 1 1, as I told, the Euclidean distance between the first data point and the first cluster center, and if you see that, so these are nothing but the dimensions of the cluster centers, the first cluster centers, and corresponding to the first data point, this is my x, y and z coordinate, and using this, so I can find out the Euclidean distance d 1 1, and this will become equal to this. And following the same procedure, I can also find out d 1 2 is nothing but square root the first data point and second cluster center. So, this is actually the dimension of the second cluster center, okay, and this minus 0.2 square, this minus 0.4 square, this minus 0.6 square, and this 0.2, 0.4, 0.6, these are nothing but actually the dimensions of the first data point. So, out of those 10 data points, these are the dimensions of or the coordinates of the first data point. So, very easily I can calculate the d 1 2, and that is nothing but 0.38010505056. Now, I can find out what is mu 1 1. Now, this mu 1 1, let me once again repeat, that is actually if you see the mu I j, that is the membership value of the ith data point with the jth cluster center. Similarly, the membership value of the first data point with the first cluster, okay, and that is nothing but 1 divided by 1 plus d 1 1 divided by d 1 2 raised to the power 8. Okay, this formula I have already derived. Okay, and if you just put all the numerical values and if you calculate, so you will be getting this mu 1 1 is nothing but 0.888564. So, I will be getting that particular the membership value. Now, following the same procedure, so I can also find out the other values, and if you calculate, then you will be getting, now this thing I have already calculated this 0.888564, just now I calculated. Similarly, the other membership values also you can calculate. So, these are all updated values. If you remember, so to start with the algorithm, so initially we actually assumed some numerical values, and after that actually we are updating those values. So, we have already discussed how to get this particular numerical value, follow the same principle. So, to get all the numerical values, exactly the same principle we will have to follow. It completes actually one iteration of this particular the algorithm. Now, if you remember, so at the beginning of the first iteration, we started with some initial assumption of the mu matrix, and now we have got slightly modified or updated matrix, and in the second iteration we are going to start with So, this particular the mu matrix, and once again we will repeat the process, and these particular iterations will go on and go on, and after a large number of iterations. So, there is a possibility that we will be getting some your the modified the cluster center and the modified values for this your membership. Now, after a few iteration, there is a possibility that we will be getting the cluster center is something like this. So, this will be the first cluster center having x, y and z coordinates, the second cluster center like x, y and z coordinate, and this will be getting after running this particular algorithm for a few iterations. So, might be 20 iterations, 30 iterations. So, it is a very simple problem. So, we will be getting this type of cluster center, modified cluster centers, and corresponding to that. So, we will also be getting what should be the modified the mu values, that is the membership function values. Now, let us try to relook what does it mean. Now, let me repeat the same thing. Now, if you see this mu matrix and if we concentrate here, what is the meaning? The practical meaning? The meaning is something like this. So, the first data point belongs to the first cluster with this much of membership value, it belongs to the second cluster with this much of membership value. Sum of their value is equal to 1.0. Now, this shows the membership value of the second data point with the first cluster center, membership value of the second data point with the second cluster, and so on. Now, you try to locate. So, out of these the 10 sets of values, and with respect to the first cluster center, whose values are very near to 1. For example, you can see, so corresponding to the first data point and the first cluster center, okay. So, this particular mu value is very near to 0, this is also 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 very near to 0. That means, your the first, then comes your the second, then third, fourth, fifth, sixth, 7th, 8th and your 9th, they are forming a particular group. Okay. And if you see, so here, so corresponding to this, so this is the membership value with respect to the second cluster is very near to 1. Here also it is very near to 1 with respect to the second cluster. Here it is in between, but you just give the opportunity to join the second cluster. So, this is very near to 1 with respect to the second cluster. This is also very near to 1 with respect to the second cluster. Okay. So, this is one point, this is another point, another point, another point, another point. So, this is the third one, third point, then comes your the fourth point, then comes your the fifth point, then 6th, 7th point, and this is your the 10th point. So, this will form another group. Now, in terms of clusters, like say it will form one fuzzy cluster something like this. So, this is one fuzzy clusters, there could be another fuzzy clusters and there could be overlapping also, okay. And might be here the first point, second point, 6th, 8th and 9th points are lying, and here there is a possibility the third, fourth, 5th, 7th and 10th point are lying. So, I will be getting one such fuzzy cluster here and I will be getting another such fuzzy cluster here. So, this is the way using the concept of the fuzzy C-means clustering. So, we will be able to do the clustering and we will be able to get say 2 fuzzy clusters, particularly for this very simple problem having only 10 numerical data like 10 data points, and we have seen that So, this FCM algorithm is able to do this clustering very efficiently. Thank you.